download, not download, but sign up for Firecrawl. Just go Google Firecrawl. It's really simple. And then you go into their dashboard. You have an API key, it's like right here. Just gonna copy that, and you have like integrations with LangChain, Llama Index, all these things. If you want to do that, they have a Python SDK and a TypeScript SDK. So very web developer friendly, like most things nowadays. Let's just install the Python package. Literally one line. So just to explain what's going on here. We have a Python runtime on the internet, and we're installing this one package. So this tool is it both has a visual interface, a GUI, and an SDK, so like a software development kit that you can use for Python or TypeScript. And we're going to be using the Python one.
So I can theoretically do this stuff with their GUI, like on their website right now.
Yeah, but obviously you can't scale that.
But
you can only.
Yeah, this is just for me to play around, and then I'll scale up the team.
Yeah, I can show you what it looks like. So.
No, I'm on it, right?
Okay, perfect.
Yeah, I've already logged it.
Cool.
Thank you.
So we got the package down. What we're gonna do now is I'm gonna put in the Invest Ottawa key. Will I use it outside of the workshop? I don't know. I mean, you can't really say anything about it because I didn't admit to anything. Okay, so we ran this cell, which just means that we got the package. That we just have to input the API key. That's how they track your usage. For the sake of this workshop, I'm just gonna create a couple of like functions to like make nice tables so we can see them better. So nothing to see here, just table creators. We're gonna save all the scrape content into one list. And then, so here's the premise. I went to school in Ohio. When I was in that college town, there was only one thing that we can do, which is go to this ice cream shop called Wits. So Wits is a very popular chain in Ohio, in the Midwest. You can find them everywhere. And they have pretty good ice cream. So what we're gonna do is we're gonna pretend to be the owner of Wits. And we want to set up an account on a chatbot website. But since we're a mom and pop shop, we don't know how to use computers. We want to use a service that can kind of help us do that as quickly as possible. We don't want to like go find all our business information and type them in by hand, right? Because we all know that by the time that we write those things down, our users have already churned. Like we make it impossible for people to get through it in a few seconds. People will already churn. So what we can do is we can make it so that they only have to do one thing, which is drop their website link in there. And then we're going to get all the information from them. Because why not, right? We can do that today. Why make them do that by hand? OK, so we create a client for Firecrawl. This is literally how easy it is to start scraping. So you create the client, you put in the API key, and then you just call .scrape URL. You pass in the URL, and then you pass in what kind of format you want. So you can either get Markdown back, which large language models absolutely love. You can get HTML and Markdown, so you can like maybe store the original content and do some heuristic, parsing. Or you can do whatever you want. Markdown is like the main use case for 2024 for large language models. So we're going to do that, and I'm going to hit run here. What it's going to do is going to go to this website of the ice cream shop, and then it's going to scrape a bunch of content back. So we got back some pictures, some content, some stuff. And then, yeah, so let's take a look here. So Markdown, blah, blah, blah. This is the content that the LLM will look at. And as you can see, we don't even see any sort of like HTML tags. There's a lot of links here, so let me just scroll. What we see actually is just the meat of the content, so like text. Like you as a human can actually read this. So it makes it really easy for the LLM to look at this and be like, OK, based on this information, I can actually do something about it. I don't have to like pay attention to like the HTML tokens or like whatever. Is everyone still following? Like, does this make sense? OK.
Straightforward.
OK. You look concerned, so I'm like, oh man. You're gonna hit me with some tough questions, but okay, cool. So we just scraped the ice cream shop's website. That's cool. We got a bunch of data back. But what if we don't know? What if the shop owner doesn't know which of their URL contains the information that is required? Because a website can have like multiple paths, right? And a website usually has a sitemap, which means you can have like about page, home page, contact page, all that stuff. We want the user to be able to just drop the root link, which is myshop.com, into it. And then the system will just have to figure it out. So that's where crawl comes in. We got scrape, which means give me a URL. I will go and find everything on that particular page. I will send it back to you. We got crawl, which means I will go to the root page, or whatever page you give me. I will look at the sitemap, which means how many more links are associated with this main link. And I will go to all of them in parallel to find the information. And I will bring them all back to you. So just imagine if you drop if you want to find out when Invest Ottawa is open, it's under the About page, but you only have the URL for the main page. You just drop that in, run a crawl request, and then it'll take a bit longer because it has to go and find it. But eventually, you will get to the point where you find the information on the About page. So crawl is more of like a hands-off thing, but scrape is more of a targeted, specific site thing. How does that sound? Depends on your use case. For crawl, it's going to run until you either run out of credits or you run out of depth. So like the site has like 5, 10 different sublinks. It's pretty quick. But like if you throw in like some government's website, that will go on for days. So what you want to do is you want to put in a spacer, so you can be like, okay, every 2 seconds or so, just randomize it so I don't get DDoS the government's website. So I would just every 2 seconds, 100 pages every 2 seconds. And then you want to do 3 seconds, otherwise it's like a pattern. They can detect that. Why am I telling you guys these things? Like it's not like, find out if these things are illegal. I don't guarantee any of the stuff you should be doing in production. But I would try it, like if I was tinkering with this. Anyways, let's run a crawl command here. Yeah, you're absolutely right. So here we have a depth of 2, so it's just going to go and find 2 more websites outside of this root URL. So again, same thing. It's actually pretty quick. Look at all these ice creams. Going back to his example, booking.com, I know that some websites, like aggregator websites, they put in artificial wait times because it gives the user the sense that the website is actually working really hard, but it's not. So you have to put in like a hard 5-second wait time or 10-second wait times, and then the website. I do have another workshop on that that uses an AI agent to like go and crawl these things, but I don't want to go off the rails and start talking about like actions and stuff. This is like the most basic scraping with Firecrawl, so let's keep it to that. Nobody's gonna get confused. Okay, so we got the 2 websites back. Again, like the results look kind of similar to the ones before. We got basically if you want to build a data set of like these websites, you can get everything about the website plus the content. And then you can run this overnight, run this for however long, and you get a huge amount of data that unless you get audited, you don't have to tell anybody anything about how you got it.
I don't remember how expensive it is. I don't think it's too...
Not too expensive. Not as expensive as spending like your engineering time building this.
No, like how much would it take for like 1,000 pages?
Actually, Firecrawl pricing. Okay, $16 a month, 3,000 credits. So 1 credit per scrape. Yep. And I think for crawl depends on how many sublinks you have. So one credit per scrape. And you said how many sites?
1,000. So it's...
Yeah. So we got. I actually just found out that you can do like calculations in here. 16 divided by 3,000. So about this much per scrape. And then times 1,000. $5.
Much cheaper.
But then again.
I was trying to scrape Canada.ca website once. It was a horrible nightmare.
Yeah, I can imagine.
Is there a way to find out in advance how many like sites or pages would be crawled on a site?
Absolutely.
Mm-hmm.
It's called a sitemap. So there are many ways you can like programmatically find out. This is like, table stakes for like most web scraping tools. And websites do want the sitemap to be available because that's how you get indexed by Google. Somebody got an Amber Alert.
Also, there's map.
Yeah, so we're actually not going to be talking about map today, but map is a really cool thing. So
Just never used it, so I'm curious what it is.
yeah, so good call. The reason why I know about map is because we had the founder of Firecrawl on a webinar once, and then he told me, and like I didn't read the documentation, but thank you for telling me. So map is basically you hit a website, you could get thousands of links, like a government website. How do you know which one has the information you need, right? But with their endpoint, with map endpoint, you can semantically search for it. So you can rank the one that is most relevant on top. So like you can always like guarantee that if I just hit the first three, I will get what I need. So programmatically, you can get the sitemap pretty quickly. But if you want to get the sitemap in an intelligent way, so you have to go through like 1,000. Because like the one you need might be like in the 500 or like the 600. If you use their /map, which is basically, the code is literally like this, but like map. You will get the one, like maybe like about page at the top. And all you have to do is just like, okay, I know the first 5 is going to include it, so I'm just going to scrape the first 5, always. So no more 1,000 URL crawl, but more like 3. Yeah, so that's a really good good call there. Okay, so we already crawl this. So our objective is we want to. So we crawl the websites for the ice cream shop. We want to gather information about their business name, and where they're based out of, their address, and what times they're open. So we don't know where that information is going to be. So we're going to combine both the information from like the regional ice cream shop's website, plus the national one, which has like all the ice cream options. Wow, this is like the best use case for LLMs. Really, two of the most like reliable ways to use LLMs: summarization and data extraction.
Summarization, data extraction.
Yeah, summarization. Of course, everybody does that. Nobody wants to read, obviously. But data extraction. So your systems, I'm assuming most of the time, accepts inputs like a JSON, right? Like you have keys and values. But like the information that we just saw from the websites, they're just text, unstructured data. We wanna transform that into something that our system will accept, which is like street address, this, city, Ottawa, or in this case, Granville, Ohio, country, blah blah blah, right? We don't want like just unstructured data just standing there in our database. It's not going to be useful for any sort of business use cases. Okay, I'm going to type this in. And funny thing about Groq is that their client signature is exactly the same as OpenAI. So if you want an OpenAI drop in, your developers don't have to change anything about their code. Like all they have to do is like import from OpenAI, import OpenAI. The entire code base is the same. Like they did it on purpose so that you don't have to like change it. So for people who aren't familiar with data extraction using large language models, all you have to do is you have to tell it that, hey, you are an expert in data extraction, and then you give it a schema. So schema is just like, how do you want your data to look like at the end of the pipeline? So in this case, we're going to say, hey, I want it to look kind of like this. So I want a dictionary, if you're a Python user, or a JSON object that has business name. The type is string, which is just text. Business address, menu items, item name, description, and then operating hours of the business. Like, it's crazy how this is how we code nowadays. Like, you just tell it to do stuff, and it'll just do it. And this model we'll be using is, I think it's an 8B model, no, 70B. So it's smaller than GPT models for sure, but it's fast and it's open source, it's free. You can even try with A/B. So this is where like this tool comes in, Quotient AI. You can sign up for this for free. Like, highly recommend. So you don't know which model you want to use. You can go in here and you can choose from like different providers. So you have like OpenAI, you have Anthropic. Everything is also free. Like, you can run GPT-4o calls for free. And then you can use like, Google Gemini here as well. So that's where I came in here and I just kind of like tested my, my prompt. So I just ran it like this. So the exact same thing, you're an expert at blah, blah, blah. And then I paste in like the scrape content from the website. I hit run, and then something's gonna come back, hopefully, or not. This is where I send my friend a bug report. I'm like, you made me look bad in my workshop. I will not renew my subscription. I will not do that. But this is a cool place to do it because you can try small models. Small models are really hard to prompt. Large models like GPT-4o, like O1, like they're so smart that you can just tell it some vague commands and it'll just do it. But for smaller models, you have to like pull out all the tricks. You have to be like, if you do this, I'm gonna tip you $200. If you do this, like, I need this right now. You must return JSON, and you say it 10 times, and then it still doesn't do it. But you save so much money, so you do it anyways. So let's try it with Gemini Flash and see if it actually works. So we're gonna run this. And then, yeah, so imagine going from like all these unstructured data now to like our JSON, which is literally, it extracted all the information out. For a developer to build this heuristic and to be like adaptable to different websites, it takes weeks. But like an LLM can just do that. And all you gotta do is just prompt it. And then, because we're in Quotient, we can say like, I like this or I don't like this. The cool thing about Quotient is that if you said you don't like this, why was it bad? Okay, the UI is horrible. I can tell it like, I don't want the backticks for JSON at the top. Because I saw that if I pass this into my system, this will break. This is still considered a string because it's got this silly thing here. That's the funny thing about working with large language models. It's very unpredictable. Like you want this, you don't want this. But with Quotient, what they do is you give a feedback down here. You build an eval data set, so you can, evaluation in Gen AI applications is very important. If you don't run any sort of tracing or eval, you will not know if your system is doing well or not. If you just, we call it vibe testing. If you just do vibe testing, that's better than nothing. But do not have eval. So I give it a comment like this. I send it back. So Quotient actually like changes the prompt. Well, in this case, it doesn't actually know what I'm trying to do. So I'll give it a pass. But essentially, the system actually takes your feedback down here and tries to like fix your prompt. And you have to do that in iterations. So Quotient AI, we're gonna try that out for eval. That's great. If you're interested in like LLM ops, so this is actually part of the LLM ops stack. Like this is like pre-deployment eval. So like post-deployment eval is like Langsmith, like tracing programs, like Helicone. So like you're tracing as your user is using it. You can also again do the same thing, build an eval data set to test against or not. But this is pre-deployment. So this is when you're like iterating on like stuff. Okay, so we got that. We got the extraction prompt. Now what we're gonna do is, you already know the answer. Of course it's gonna work. I already showed you on the Quotient. So we're gonna run that against our scraped markdown. So again, very similar to OpenAI. You just pass in a system message, which is you're a data extraction expert, and then this is the content, my message. And then make sure always you set the temperature to 0 so the model doesn't get too creative and make stuff up. Somehow I feel like I want to censor myself because like Parisa is here. I'm like, I'm not gonna say anything wrong. But yeah, okay, so extraction, so we're just running this now. Yeah, obviously it works. Like the entire business details is laid down here. No more unstructured content. So now it's business value. It's pretty clear. Any questions about anything so far? Okay, cool. Now we're just gonna merge two, because like for this example, the regional ice cream shop information was one site, and the options for ice cream is on like a different site. So now we're just gonna combine them both together. So now we have like, everything about the user all in one object, and your system will take this object now and then create a new account for them, do all that stuff behind the scenes. Yeah, that's pretty much it. Do you know what? Well, customer acquisition, right? Like you want to grow as fast as possible. You want to acquire more users. So let me show you the Firecrawl lore, because I've been following these guys for a while before we even got connected. So the founders went through YC in winter 2023. Back then, ChatGPT just came out, and like everyone's like crazy about put ChatGPT on your website, right? So they were doing this thing called Mendable. Same people, the exact same people. So Mendable puts a little chatbot on your website. So you can ask questions about like, hey, what's your opening hours? Your documentation, how do I write this code? And they were competing with companies like Kappa AI. We had huge issues with our pipelines trying to ingest companies' websites and to keep them up to date. Because what they do is they would try to, like, let's say they made a documentation site for like MongoDB or OpenAI. They would have to go to openai.com/documentations to like scrape it. But then it's inconsistencies, right? So it's like, oh, they updated the documentation, we gotta scrape again. But then this part is different from this part, and like, we don't know, blah, blah, blah. So the results weren't that great. So what they did was they actually extracted out the scraping engine out of their Mendable code base, and then they open sourced that. So Firecrawl, GitHub. So they open sourced that, and now it became like crazy popular, like 17,000 stars on GitHub. So you don't know what stars on GitHub represent. It's developers' popularity. It's like a popularity contest, basically. So compare that to like, I don't know, like LangChain, which has a crazy amount of stars. They found the problem, which was, we had really huge issues with like scraping our customers' website. So now they're doing Firecrawl full time. They're shutting down Mendable. But Firecrawl is like, when you follow the guys on LinkedIn, you follow them on Twitter, you can see that they're launching stuff constantly. So it gives you confidence that, hey, this tool is being worked on. For Gina AI, for example, Gina AI is, if I don't use Firecrawl, I will use Gina. Yep. For these guys, it's a little bit more secretive. Firecrawl, they charge you, you're like, okay, I'm paying money. Yep. Gina is like, we don't even care. This is not our main product, but you can use it for free. Yeah, it's a little bit sketch. Yeah. Awesome.
Thank you.
Thanks, everybody.
Thank you very much.